This is to give you a overview of the data set that I'll be using frequently in class. It is a student presentation that I created while I was auditing my colleague's class. So my topic that I chose was, can you guess the temperature by looking at how people are dressed? The particular course this was for was a course where the students had to go out and collect their own data. So I actually did data collection as opposed to getting a set of data online. So the idea for my problem was, when I lived in Ithaca, my husband and I would go out to eat, and we'd eat in College Town and watch the students walk by. And we conjectured that we could guess the weather by looking at how people were dressed. And so this turned into the topic for this little project. So I'm going to explain my little model and how I collected data and some fun results. By the way, nothing surprising. This is all just meant to be a student exercise and to show techniques for collecting data and processing them and so forth. Okay, so how does temperature relate to body skin exposure? So the rule of nines is something I stole from EMT class. I took EMT class when I was in grad school just for fun. And you can split the human body up into pieces. So 9 times 11 is 99, plus 1 more gives you 100. And so if you look at this diagram, there should be 11 copies of the number 9. 11 copies of the number 9 and a 1. And that roughly gives you the skin exposure. So for example, a whole arm is 9. That's why they didn't write it on the other arm, but the legs count more. So a front of a leg is 9 and a back of a leg is 9. So arms count twice as much as legs. And this is how EMTs determine how much of your body is burned, for example. If you have a 3rd degree burn, 2nd degree burn, whatever, and they use this as an estimate for how much of your skin is burned. Okay, and then you can look at it in a more clinical way. They would have like an actual diagram and they could show where the burns are or so forth. Okay, so I did what I called an adjusted rule of nines. So I used the same idea, but I counted each hand as 1.5%. The arm minus the shoulder, I counted as 7.5%. So I still sort of stuck to that rule of nines idea, but I tried to estimate the body exposure, and I assumed that if a person is probably going to be dressed symmetrically right, left. People usually do. So for example, if somebody has no hat, I would count that as 9% exposure, but if they have a small hat, I would call it 7% exposure. A warm hat, I'd say, 5% exposure. And same thing with sleeves. I would prorate the exposure based on how long your sleeve was. But I just had these certain categories that I determined in advance based on typical things people would wear. Here's an example. If a person walks by, I'm assuming that the person has no hat, and so 5% exposure for that. The person is sleeveless, so that's 15%. Hands are exposed. Drop neckline gives another 5%. The person is wearing sandals rather than shoes. That gives another 2%. So I add these all up and give 32% exposure. Here's another example. This is the most common. You just see a person like that, you say, okay, head is open, regular neck, hands, and then you get yourself 14% exposure. That's the most common number in the data set. And so I decided to go out on, all over campus. But I did a lot of my data collection on the quad at various temperatures. I did it as we were transitioning from cold to warm, whatever spring I did this. I think it was 2016, but I'm not sure anymore. So when you're taking surveys, the old-fashioned way is to have a clipboard and look really obvious, like you're collecting data. But we're all spaced out on our phones anyway. So if you're just spaced out on your phone, nobody's going to ask you what you're doing. So I just wrote an app so that I could collect data through my own website. Okay, so the benefits of an observational study versus a survey: you don't get any non-response or lying. That's just not part of your problem. Okay, benefits of using an app: there's a lot of controls for the data error. You can automatically log time, IP address. You don't have to remember where you put the survey form. You can collect lots of data quickly, since you only have to click instead of writing things down, and you can choose which choices to reset and default to, so that, since I wrote my own app, I could do whatever I wanted. And when you're using an app, nobody cares what you're doing. Nobody asks you, hey, what are you doing? Actually, maybe I had 2 people. The whole time I was doing it, I think I explained it to 2 people. But I collected a lot of data. So what I collected was gender, age bracket. I collected either somebody who was college age, middle age, or older, exposure units as components, and I later added them together in SPSS. I indicated whether or not they had jacket use, umbrella use, blah, blah, blah. Okay, I'm not going to go through all this. And this is what my app looked like, and then I just clicked whatever category was appropriate and hit submit. These are some of the places I collected. You see these little red lines. I would just say, okay, I'm going to sit in a certain spot, you know, at the corner of one of these like little triangle things. And then just sit at one of those edges and say, if anybody comes into my triangle zone, I'm going to count them. That's basically what I did. I had 865 observations, and there you go, some data overview. And this is what happens if I tried to fit a quadratic and a linear to my observed data. So I put the current temperature in Fahrenheit along the bottom against exposure. So this is just all my data. It doesn't look like there's as much data as there is because there's a circle on top of another circle. It just shows us one circle, a dark circle. Here, just to demonstrate how to make some histograms of some of the variables. So for example, legs, if you see legs, 0 means most people wearing pants. So 0 exposure was the most common, and then some people wearing shorts. And what hat, most people did not have a hat, so they were marked as exposed. And feet, most people have full shoes. There are some people with like sandals. And then another thing you could do is you could slice out a particular temperature and see what the distribution looks like for the whole temperature. So for example, at 48 degrees, then there was a spike here at 14%. That's the most common spike anyway. So when it's chilly out, most people aren't exposed. But you can see as it gets warmer, here's 68 degrees, then more people are going up into the upper echelons of exposure. Okay, so this one is 84, this is really warm. Then what's happening is these people down at 14%, they still exist, but a lot more of them are just shedding layers. So it's the same people who would have been here in this bar, but they take their jacket off and then they walk around without their jacket. Okay, so I can ask questions. I can say, do women expose their body more? Do women expose their feet more? So specifically I can ask about their feet, or I can just ask about the overall exposure. In both cases, Levine's test says yes, and so this is all my SPSS output. Chi-square says people wear jackets or coats differently depending on whether or not it's sunny. So I had this sunny variable, and it's supposed to, when you do this test, it kind of should kind of wash out whether or not there's a temperature correlation, but I mean it doesn't really. It's going to be more sunny on warmer days, so there's some kind of a lurking variable, but anyway. Let's see, I did a gamma test. How did I even do that? I don't even remember. I created temperature bins. So gamma is something we probably will not talk about in most of the classes I'm teaching, but if we do, then you can look at this slide. But I created these bins artificially just so that I could do a gamma test, and of course it's significant. But I didn't have to bin the data because it was already continuous data to begin with, so this was kind of bogus. I just did it to see if it would work. Of course it did. All right, so now scatter plot by age bins. I wanted to see if, so here are the different levels of ages. I think 1 was college age, 2 was middle age, and 3 was older people. And you see middle age and older people are pretty much the same. College students are more eager to take layers off. I mean, that sort of resonates with your experience, but just also keep in mind the practicality. A lot of college students already live on campus, and so people who are older tend to go elsewhere for home. So whatever clothing they wear, they're more conservative because they're not going to go home and change in the middle of the day, and college students might. So there's one thing that's going on. But, you know, age affects people's attitudes about what they wear. But this one is my favorite. This is the male-female scatter plot. And it shows, so I guess Male, 0, so that's female. So the colors are reversed of what you're used to. Blue is for girls and red is for boys. Okay, so anyway, the women expose more at higher temperatures, but they bundle up more at colder temperatures. That's what it's saying. Okay, so here's the whole data set. You don't have to look that carefully at this unless it's part of what we're covering in class. But there's just all neat things you can do with SPSS. Oh, and I did another thing. I said, you know what, I really want to, I just eyeballed this. I just said, what is the top value in each category? Because people can, for each temperature, there's somebody who stands out as being the most exposed person. And I just wondered how explanatory that upper edge of the data would be in determining the temperature. That was my original hypothesis in Ithaca, was that it wasn't so much what the average person was wearing, because a lot of us dress out of habit, but the people who really embrace the temperature and say, hey, I don't want to wear any more clothing than I have to. That group of people up here, I wondered if they would do a better job predicting the temperature. And so these formulas look like this. If you're just looking at the average person, then the predictive model is the temperature is that exposure plus 9 times 2. And then the other model says if you look at the most exposed person, the temperature is their exposure level plus 5, which means you could never get anything over 105 degrees. Then that person would have nothing on. That's what it's saying. Doesn't mean it's true, but that's what it's saying. Okay, so at 105 degrees, somebody will walk around campus looking like this. And the other model says that at 218 degrees Fahrenheit, the average person will do this. But the hottest recorded temperature ever is 134, and humans cannot exceed about 140 degrees for over 10 minutes. They will not survive. Okay, so what about this? When is somebody going to be completely covered up except for maybe their eyes? This model says at -5, most people will want to cover up. The most exposed person will want to cover up everything. We know that's not true. I've walked around at -5, and there's people with their hands exposed. You know, whatever. But that's what the model says. And the model says that at 18 degrees Fahrenheit, a typical person will want to cover up everything. And again, that's not true, but that's just our model. Okay, these models are completely faulty, but this was just meant to be a cool data set to show you some things you can do with data. And so now you know, when I reference these data sets, this data set in class, you'll know what the underlying story is about that. Hope you found it fun.